Hey everyone, welcome back to Unbound Coder. Here we break limits with code. So today we will solving the most interesting some DP problem. Basically, it's the 2D DP problem, and this is the common pattern of 2D DP problem. Okay, so if you solve any of particular problem, we will solve most of the common problem. Okay, in 2D DP. So I will pick up any of this and I will only write the base case and the main which are the stuff and what to find it. This all the in lead code problem you will search the question in lead code or GFG, you will find it. Okay, so first problem ke grid unique path one or two. So what the problem statement, the problem say that mm, so the grid unique problem say that this is my grid. So one man is here, ठीक है, top one man is here, top is what this said, top right, top left corner. Okay, and he will reach in this top right corner, so sorry, bottom right corner. So how much way he reach here? So he have two choice, or he go till here, what say, this is my right, and all he down. Okay, so how much way he reach here? So if you do in recursion there are multiple stuff, but the grid unique path one problem is also possible to solve in greedy problem also, but this is DP playlist, so I will make the video in DP. Okay, so what say, if you know that this is my starting point and this is my ending point and this is the fixed point. So if you do for recursion from last to top, you will get the answer. So what you pass in your function, you pass function or what this value is m minus 1 and n minus 1. Okay, so this is my row column m minus 1 and n minus 1 row column, and you pass the grid. Okay, okay, so what is my base case in the problem? My base case is when you reach r equal to my 0, and also column equal to my 0, then return 1. Okay, okay, or obviously what is the another base case? If any time cross boundary means my row exist boundary, matlab means r r is less than 0 or r is greater than my m, so then cross the boundary. Or if my column is less than 0 or column is greater than my column size, then it reach the boundary. So when reach the boundary, you return 0. Okay, and what is the my possible stuff they can go? So if you backtrack from here, you will see that is the two choice. If you from top, you down and right, but if you from last, so you will go from left and up. So up, when you up, so what we see that my row is decrease. Also when row decrease, you go up, so row decrease but column is fixed. So what you write, my row minus 1 and column fixed, so column. Okay, and function pass grid, and when you see left, my row same but column decrease, so r minus c minus 1. Okay, r comma c minus 1 and grid. Okay, and last what you return up plus left, because this is the total way you can reach in that top corner. Okay, so when you this is my recursion, and recursion time complexity is how much choice I have, two choice in every step. I have two choice to, so 2 to the power n, this is exponential, we not do it. So what we do, we do recursion. By recursion, first of all need a DP table. So by here, first of all you see that what is the changing parameter here. So here the changing parameter my up and left. So up, left, for two changing parameter we need 2D DP. Okay, for three changing parameter we need 3D DP. That's the thinking how you need how much DP. Okay, so how you first of all write that vector or vector integer for C++. For C++, then write DP, then first of all size row, then again vector integer, integer, and then size column, comma, -1 initialize. And when function call here, write that if my dp I matlab what here means what here row, so r c not equal to -1, then return this value dp rc. Okay, and then function call and last to dp rc equal to up plus left. Okay, okay, so this is my memoization. In memoization, what is my time complexity? Memoization time complexity is my big O n for row, and for column big O m, n cross m. And what is my page complexity? Page complexity also my for dp fill up, so big O n cross m. Also another auxiliary page for recursion, so big O n cross m. Okay, and I am not satisfied in memoization, so I will do the tabulation problem. So if memoization is my top down, so tabulation is my bottom up. So what I do, so by first of all write the base case. So in base case what I write, so in tabulation what you write, only two loop, for loop, first loop I means row equal to 0 to till go n, and my column for c equal to 0 to till go m. When you see my grid row and column equal to means, if you write that, not you write this, if you write r equal to 0, and c equal to 0 means column equal to 0, you write dp rc equal to 1. This is first if, and if it not, then you write first of all up and left. When you write up, you write dp r minus 1 and c, and when you left, dp r same c minus 1, and lastly dp rc equal to up plus left. That is your answer. When you do is space optimization, what you do, you see there is my r minus 1. Okay, so what you write, you make it previous, so here is the previous and here is the current value, and change it, you do the pace optimization. Okay, so this is grid unique path 1 problem. And when you do unique path 2 problem, there is a one conditional check. If my grid 1 is the obstacle means here have any rock. Okay, so then my man not go here, so only need to check in the base case. If always check the, always this check in the above, because when function call, if my rock is here, then not insert here, so always write that this is unique path 2 problem. Okay, unique path 2 problem, so here you write that when my grid rc equal to 1, return 0. Okay, okay, and that's it. And always here in every step r minus 1 means kya, means r always need to greater than 0, and column need to mean base case check here. Okay, greater than equal to 0. Okay, and that's the two problem, grid unique path 1 and unique path 2 problem. And if you see minimum path sum problem, this is the same type problem, only want to know, I will see you example. Okay, so here say that what is my minimum. So in the problem say that which give my minimum sum in the here. So if we go from here, we go here, then we go here, we go here, we go here, top here, also make possible here to here, to here, to here. Okay, so which give my minimum? You see this give you minimum path. How you find it? Same to same the previous approach, only here check, only here check when you write up, then you always first write grid of RC and plus this dp of r minus 1c, and you close your eyes and write the whole case. Okay, and when you left, same grid RC and plus dp of r minus r c minus 1. Okay, and here c. Okay, last what you return, dp of RC equal to dp of RC equal to minimum of up left. This is the minimum path sum problem. Okay, this is the same problem. Okay, and when you do triangle problem, what you see there? So in triangle problem say that, so in triangular problem here is the simple tricky things here. Here say that from start here and anything anywhere you go, the last row which you give minimum is your the answer. So you notice that I first of all write the whole grid. Okay, you notice that when my I is 0, there is 1. When my I is means when one row one element, two row two element, three row three element, four row four element. This is the tricks here. And if you start here, you only want to go, you see, if you see the question, you go only down or you go only the diagonal. So down means what? Row plus 1, and diagonal means row plus 1 and column plus 1. Okay, okay, so I not go from the last because this is my variable, here not the fix. So what I do, I traverse from the first. So what I pass in the function, I pass from row 0, column 0, and my triangular grid. Okay, okay, and first of all write the base case. When you first of all handle the base case for minimum you write, when boundary cover you write means r, if less than 0, then you write r never is possible, it always c possible. Okay, so when c, then you write when c is greater than n means column size, then you write return 1e9 maximum value. Okay, and this is the check boundary, and you write first of all this is my base case, and all one more base case is the final answer. Okay, so when you write r equal to my m minus 1 means when r plus 1 you go till you came here, you write when my r equal to m minus 1, you write triangular of, you return triangular of my row and column. Okay, and then you find my down stuff and diagonal stuff. For down you write triangular rc and plus f of r plus 1 for down means r plus 1 comma c and triangular, and for diagonal triangular rc and plus function r plus 1 c plus 1. Okay, and my triangular. Okay, and lastly you return minimum of down and diagonal. Okay, this is my answer. So when you do memoization, take a 2D dp table, and there you write dp of row column equal to my this, and always check above the function call here, if my dp of rc is not equal to -1, it's the main in the memoization. Always in recursion to memoization is the simple technique. First of all, check, first of all, create the dp table, okay, and as initially is -1 for first. Second, pass the pass the function, pass the dp in the function, okay. Third, check check is not equal to -1, and fourth, assign it dp, okay. This is the memoization simple. So what is this time complexity? Time complexity equal to big O n cross m, row and column, and pace complexity equal to big O n cross m, and for extra auxiliary pace for recursion, so big O n cross m, okay. And I am not satisfied in this, so what I do tabulation, and tabulation, what tabulation start from um, memoization top to down, and tabulation start to bottom to half, up. So I start from here to here, so now I start from here to here. So first of all, what I write a dp table 2d dp create, and write the n minus 1 all value, okay, which give my value, okay. And then, so first of all, write the last value in here, and then what I do, for loop, I run a for loop. I go in minus 2 to till go 0, and another for loop. This is for row, and this is for my column go till r, because you see, I first of all you say that when my I equal to 1, then my 1 element, when 2, then 2 element, 3 element, 4 element. So I write c equal to r, c going to till my c go till 0, and c minus minus, okay, okay. And then the same table, only write dp of r plus 1 and c, and this is for my up, triangular rc plus this, and dp of r plus 1 c plus 1, okay. And lastly return dp of rc equal to minimum of up and up, not down and diagonal, down and diagonal, down and diagonal, okay, okay. And if you do a space optimization mode, you will see that here have r plus 1. So I see one thing, if you cover this, you also need to cover this, okay, from this value to this value. If you cover this value, then you will came from this value to this value. So what I write, I need to write the front. So if I make the two array, one name is front, so I change is here the name front, and another I change here front, and lastly return front of my 0, okay. Because I lastly write what dp of, when tabulation dp of 0 0, I write the value, and so here this, okay, okay. This is my triangular problem, and this is the here in the this video, this is the main important video which I say you minimum falling path sum, okay. Okay, so this is the main problem of this video, minimum falling path sum. So in here, here not the fix the first row, here anything anywhere start from here, and anywhere start from the last row, mean finish in the last row, okay. So if you see that I first write 1, then write 5, and then I go 7, okay. Then this is my 1 5 1 6 and 7 13, and if I go 1, then 4, then 8, what 4 1 5 and 8 5 13. So 13 is the minimum, and nothing give 2 6 2 6 8 8 6 7 15, means only 13 is the minimum path sum. And in here, why I go here and here, because here clearly say in LeetCode or GFG, you see that I only can go down, left, and right, means in down, here and here. When you go just down, r plus 1 and column. When you go here means left r plus 1 and column minus 1, and when you go here you see r plus 1 and column plus 1. Okay, this is the matrix. Okay, so I will write first recursion. So in recursion I start from anywhere. Okay, so I start row from here, last row, and last row any column. Okay, so what I say, so for loop, I means column 0 to go, column 0 to go, column size, column size what here, c dot size. Okay, means grid dot size, grid dot, if in square then my row size and column size is same. If not square then you write grid of 0 dot size, then you find the column size. Okay, okay, so c0, c greater than go, I write it m. Okay, and c plus plus, and then you first of all here find the minimum. So you write a maxi num, maxi, which initialize int maxi, not mini, because I need minimum path sum. So I write mini, which initialize 1 e9 max value. So here you write mini equal to my minimum of mini, comma, function of n minus 1 row and any of the here column and my matrix value. Okay, okay, then you came the main function, you write row, column, matrix. Okay, you will write the first of all base case. What is the my base case? If you cross the boundary you always return. Cross boundary means if r, if r is less than 0 or column is less than 0, if r is more than m or column is more than m. Okay, then is my out of boundary, so I will return 1 e9 max value. If not, I will normally return and also write if my I means row equal to 0, anything here I write matrix of row and column value. Row means 0, 0 and column value anything here. Okay, I write and my choice, then I write my all possible stuff. Okay, so first of all, down, for down what I write, for down I write matrix of, matrix of row, matrix of column plus function of what I say for down r plus 1, and for when you go top, so what you write then r minus 1 and column minus 1. Okay, okay, just below, and when you go left then you write matrix row column plus function of row minus 1, row minus 1 from here to go here, row minus 1, and my column row minus 1 and my column also minus 1. Okay, but here not column minus 1. Okay, so down column is same, but when you go left then column minus 1, when you go right then here is my fault. Okay, sorry. So here you write function of r minus 1 and column plus 1 for right. Okay, then you find maxi equal to return maxi. You say that return return max of my down, comma, max of left right. Okay, left right, which you give the maximum. I will I will, sorry, here not maximum. When maximum falling path sum then I write maximum, when minimum falling path sum then I write minimum. So here write minimum. Okay, minimum, and I will also check here. Okay, which give my minimum, this is my answer. Okay, so in recursion what is the time complexity? Exponential, because I have 3 choice, so 3 to the power n, it is exponential. So do it memorization, how you do it, only when function call here check. I see you every video in every video in past, and also memorization is simple. If you find the recursion then you only check. First of all, this is the process. You create a dp table, pass the dp function, then check the -1, and what last write, assign the value. Okay. Okay, then what is my time complexity? Big O n cross m. If my row and column same, then you write big O n cross n, and paste complexity big O n cross n plus big O n cross s. Why? Because auxiliary paste. Okay. Okay. So now is come for tabulation, because I don't write the extra space. Okay, I remove it. I want to remove it. So what I do? So I do tabulation. First of all, write. So in tabulation, first of all, write the base case. What is my base case? First of all, in 2D DP, in 2D DP, I write the variable value in the matrix which give it. I write as it is here. Okay. Then I start a loop from here to my last row, and also I start a column from 0 to last column. Okay. So what I write? My for loop I equal to 1 to till go n, and for j equal to 0 to till go my m, if my row column is different. Okay, then you write first below. Below means down. Okay. In down there is not what say, there is not boundary cross. Okay, because you just write here, so you write matrix of ij plus matrix ij plus dp of I minus 1 and j, not change my column. Okay. Okay, and then you write below and left. In left there is cross boundary. When you go here, okay, then the cross boundary. So what you write? If my column value is more than 0, then you write left equal to same matrix ij plus dp of I minus 1 and j minus 1. Okay, and in right also it's possible to go here, so cross the upper boundary. So you write if my c is less than m. Okay, then you write my same matrix ij value plus dp of I minus 1 and j plus 1. Okay, and finally you write dp of I j equal to which you give minimum below and minimum of left and right. Okay, and lastly you assume that that int mini equal to my dp, because in last you see that my last row is full of value. Okay, here 1 2 3, here 0. Okay, so what you see, you write that minimum equal to my last value dp of n minus 1, n minus 1 or 0. Okay, then a for loop I equal to 1 to go last m column value. Okay, and check mini equal to what? Mini equal to minimum of my current mini and my I value, means what it say, dp of n minus 1 I value. Okay, check which you gave the minimum. This is your answer, mini. Okay, and it's easily possible to pace optimization. Why I just teach you that, why where you see I minus 1, this is always possible the pace optimization. So most of the case not need to write space optimization, but you if you do competitive programming, then obviously needed the pace boundary, so always write the pace optimization. But if you do memoization, still okay, and try to possible do tabulation also. Okay, and lastly here write previous, and here also write previous. I have no tabs, so I don't cut the cut the my writing, and so adjust it please. Okay, so I in the video I say you and teach you only the approach. If you need to revise, then it's very helpful. It's also save your more time. I also um, I also same revise using in this video. Okay, and in till go after day after, I also want to give my best in the teaching skill, and that's it. And if you need the code, in the description I will write the every code. There is my github repo, and you also do. When you write any problem, you will also push in github, because when you need to revise, you will follow them easily. Okay, because sometimes you see lead code and gfg not save your answer, so you also push in your github for your referencing. Okay, so I will not code now, you also follow my answer sheet in description. So today that's is for today problem, and if it help you, hit the like and subscribe to Unbound Coder, and let's keep breaking limit with code. I will see you in the next one. Keep coding, keep growing, and keep grinding. Okay, tata.